Let's talk about stage 1 for lab 6. Now we know the description for lab 6, kind of, stage 1 and stage 2, the whole thing is that what happens is we have this empty tank. When it empties, liquid starts to fill. When it gets to the top, then a heater comes on and heats it to a certain degree. And then once it's reached the set temperature, a mixer comes on and mixes it for a certain amount of time. Once that's done, it empties, and then once it's empty, it does the whole cycle again. So that's kind of lab 6 in total. Stage 1 is what we're going to do is we're going to design a system that when it empties, it gets full, turns a heater on, and then turns a mixer on for 5 seconds. And that's it. Then in stage 2, we're going to figure out how to actually make it empty and then fill again. Yeah, and that's actually pretty complicated. So we're going to walk through this kind of bit by bit, and I'm not going to give you everything, but I'm going to talk to you about kind of what we need to do to make each stage or each part of each stage work. Okay, good. So, and what you need, I strongly suggest you get a piece of paper and a pencil because you're going to erase stuff. And if you just follow what I do, I'll be erasing stuff as well. Because the design process is kind of like, okay, I'm going to just make one thing happen first. Once I get that happening, then I'm going to go on to the next step. And then the next step, there may be a little bit of a conflict from the next step to the first step. You may have to tweak the first step just a little bit. That's why I've got whiteboard pens and a whiteboard, but a pencil and a piece of paper are good. Don't use lined paper, don't use graph paper. They just, all of those lines get in the way. Okay, here we go. I've got this tank over here. So think event programming. We have to think about the events. And by the way, do it on paper first and then stick it at Automation Studio. And you'll know how to do it in Automation Studio because you've already done lab 5. Right? Yeah, get on that if you haven't done that. Okay, let's get on this. Okay, what we're doing is we're doing event programming. We're going to think about the events that happen. Remember, an event is just something that happens. It's not an electrical thing. It's not like the contact in the switch becomes closed and the electricity goes here. No, it's just something that happens. Door opens, liquid level goes up, temperature changes, whatever. Pressure goes below the set point. In this case, we're talking about liquid level. So the liquid level goes below the lower level switch. So I'm going to label this. This is my lower level switch, and this is my upper level switch. We're going to need both of those things. There's a temperature gauge in here, but we won't put that in yet. Again, like I said, just one thing at a time. Okay, good. So what we're going to talk about is the liquid going below here. So when the liquid goes, by the way, this thing is going to be energized. Now, that's a solenoid valve. We haven't really studied solenoid valves, but we will in pneumatics. But just believe me, a valve is a physical thing, right? Well, you can make it move with a solenoid. Yeah, just energize the solenoid and it'll pull or push the valve. Okay, good. So if this is energized, so essentially what's going on is, because this is energized, the liquid is going down. Okay, when the liquid gets below here, what's going to happen to this? Well, it's going to give us an impulse, an electrical impulse of some type that says, hey, an event has occurred. The event is it got below the lower level switch. Okay, so we want that event to start something. So we could actually think about whether this should be a normally open or a normally closed. I mean, we could draw both of those. So let's just take a look at this. A level switch looks like this. And we can draw it like this. Whoa. Okay, that's a normally open level switch. And this guy is a normally closed level switch. And we can kind of think about gravity here. So, or the liquid level and gravity. So, gravity is kind of keeping this pulling down, right? So when liquid goes to it, it becomes closed because it pushes it up. In this case, gravity is keeping this down so the contact is closed. When liquid goes here, it becomes open. So we have an option of either a normally open level switch or a normally closed level switch. So we may want to just start with one and maybe we'll change it later. Okay, I'm going to start with a normally closed. The reason I'm doing that is because I want to get an electrical impulse when the event happens. In this case, the event is it's empty. So if it's empty and the liquid goes below this, it will become closed and then I'll get an electrical impulse. So I'm going to start my ladder with this. Now, we know at some point we have to put a start-stop in here. like I said, do one thing at a time. The start-stop is kind of almost an afterthought. You know, it just kind of turns it on and turns it off. So I'm just going to kind of throw that in a bit later and try and figure out how to put that in a little later. Right now I'm just going to focus on the events themselves that are outside turning it on and turning it off. So now I have some more space. Okay, good. So I've got 0 volts here and I've got my 2 rails. I know that what's going to happen is, and I got lots of room up here, whatever, because maybe I'm going to erase the whole thing again, or if you're doing it on your paper, leave a little room on top of it so you can add a start-stop because it's going to be on the top. Okay, here we go. So I'm going to put my normally closed level switch in here. Okay, and I'm going to label it. This is the lower level switch. So in this case, I want to drive a relay with it. Now, essentially the reason I'm driving a relay is, well, we know that it's going to drive the pump. Let me just put the pump in just for fun. Let's put the pump in, okay, because we know that this is the pump over here. I'm going to label this as the pump. Okay, good. So actually we're going to put the motor here because the pump is an actual physical device. That's a motor, maybe sub pump. Okay, so that's the pump motor. Okay, good. So let's just say that this was what we're going to use, because essentially what's happening is the event is going to turn the pump on. But the problem is the event goes away really quickly. Watch this. As soon as the level goes below here, that becomes closed and the pump comes on and the fluid starts to go in and the level goes up and then this becomes open. And we got a problem. Obviously we're going to deal with that with a holding circuit. So what I'm going to do is I'm going to put my R here. And I'm just going to start even with an R1, even though I know I'm going to need an R1 in my start-stop station. But again, I'm going to change some things here. So I could start with an R1 or an R2, but I'm just going to start with an R1. And then in this case, I know that I need to put a holding circuit around here. But you know what? If I'm going to put a holding circuit, I need a contact over here that's going to be a termination contact. Wow, okay. So what I'm doing here is I'm going to do this guy, moving him over a little bit. It's a lower level switch, and I'm going to put a contact on here, R1-1. Sweet. So I know that when this signal goes away because the fluid's going up, I'm holding onto it. I've latched onto that signal. I'm remembering that it happened. Now this relay is going to remember that this event happened. I know that that relay is going to turn a motor on. So I could actually do this. And then just put them in parallel, and that's a motor over here. So what I could do is this. Now that may be okay. I may find a little later that I may have some other reason that I want to turn this motor on, so I may have to put this on a different rung so I can add more logic there. But for now I'm just going to roll with that, because as far as I can think of, the only thing that turns the motor on is this event. So I'm going to roll with that. Okay, good. So where are we at? Well, we know that it always points, these termination contacts always point to the next thing, actually. Now what's going on is that now somehow we're going to have to turn this thing off. I think that'll come a little later, because we were assuming that this was on when this happened. So we'll just kind of think about that later, again, one step at a time. So when it gets full, what do you want to happen? Well, in this case, we actually want two things to happen. The event is, it's full, right? So now, this is going to give us some kind of electrical impulse. My upper level switch is going to give me an electrical impulse that says, it's full. I have to think about whether I want that to be a high impulse or a low impulse, in that, if I want that to be a normally open or normally closed. What do I want to happen when it gets full? Well, how many different things should happen when it gets full? Well, think about it. Should the pump stop? Yeah, definitely the pump should stop. Okay. Is there anything else that should happen? Well, yeah, right? The heater should come on? Okay. So I have to have two things that happen when this happens. So if I'm going to put that here, do you know what? Just for safety, I may have to hold it. I'm going to put my contact over here because I may have to put a holding circuit, and then I'll need a termination. So, and I'll tackle this a little later. I'm talking about this. So that's going to be my level switch. I'll think about whether it's normally open or normally closed later. Over here, what is supposed to happen? There are two things supposed to happen. One is that that is supposed to shut off. And the other is that the heater is supposed to come on. So do I put a heater there, or what do I do? I think you know this one, because I have to multiply a signal. I'm going to put a relay here. Relay 2. Okay, good. So the two things that have to happen is this has to shut off and I have to turn a heater on. Okay, the heater coming on could look like this. It could look like that. Now, what's making me think about this is how many different things are going to want to control the heater, or how many events turn the heater on? Is it like maybe I'm going to have some other switch somewhere in an operating room that says, hey, if Buddy presses this switch or closes the switch, it overrides everything and it turns the heater on? If that was the case, which in this case it isn't, then I may want to put this on a different rung. But in this case, it seems the only event that turns the heater on is when it gets full. Okay, so I'm going to leave it like this for now. Again, if I need to add more logic to this heater, I'm going to need to put it on another rung and grab a contact from here. But for now, what I'm going to do is I'm going to think about my level switch here. Should it be a normally open or a normally closed? Well, I want the event to give me a high signal when it happens. Just like this. No matter what, when this event happened, I wanted to give me a high signal. This event is something going away, or the level going below. In this case, it's the level going above or reaching it. So I think if I used it normally open, this is my upper level switch. If I used it normally open there, it would become closed, and then I would get a high signal that turned the pump off and also turned the heater on. Okay, good. So now I have to draw a heater in here, but I also have to continue with this. I need a termination contact here. I think you can see where the termination contact comes from. Like I told you, I'm not going to completely fill this in. You need to think about it yourself a little bit. Okay, good. I'm going to draw a heater in here. By the way, the symbol for a heater looks like this. It has 3 lines in it that are equidistant, and that's a heater. So I'm going to call this heater. Okay, good. So now I've got my heater, and that's there. So now when that closes, my heater comes on. Okay, so what's supposed to happen after that? I know I'm left with the termination contact, not here. I'll probably need to put that in some other time. So what's going to happen here? You figure out what to put here. What's going to happen next? And what event is going to make it happen? Well, the next event really is, what are we doing now? What's happening? Well, the tank's full, heater's on. And the next event is that the temperature goes above the set point. So I'm going to take a temperature contact and I'm going to put it somewhere. Okay, good. So a temperature, again, I'm going to run it all the way over here because I may need a holding circuit on this. I don't know, but I'll look into the parameters to see what's going on. So in this case, what I'm going to do is I'll have to move that up a little bit. Actually, I'll just sneak this down. No, I'll do the whole thing. Okay, here we go. Wait. I'm going to come down here and I'm going to put a contact in here. And this guy is going to be what? Oh, well, I'm using the event of it getting hot to do something. What's that event supposed to do? Well, if you look at the description, it's actually supposed to turn a mixer on. Okay. So I could actually put a motor here. Motor mixer, the mixer motor. The mixer motor is going to come on, and we know that it's supposed to come on for a certain amount of time as well. Okay, so if I do this, what kind of contact am I going to put in here? Well, you guys aren't familiar with these contacts, but I'm going to use a normally open temperature contact. So I'm going to call this temp, and I'm going to set it to 90 degrees Celsius, and a temperature contact looks like this. Okay, good. So what's going on now is that when this closes, it tells the system that this event has happened, and I want a motor to come on and a timer to come on. Now, really have to think about the motor. How many things need to control the motor? Like we did this. This is a theme here. When I put this pump in, I thought, how many things need to control that pump? Well, really only one event controls that pump. How many events control the heater? Really just one. I mean, just for now. But how many different events control the motor, the mixer motor? Actually 2. One is the temperature rising above the set point. The second event is the timer stopped counting. The timer stopped counting. So I can't just put it here because I need to have it probably in an entirely different rung because I need to control it with more than one event. So what I'm going to do here is, again, I'm going to put another relay in here. R3, Now I have my R3 contacts and I can do a bunch of things with my R3 contacts. Okay, so what I'm going to do now, I'm going to think about events that need to control my mixer. And the control aspect of the mixer is one of them turns it on and the other turns it off. Okay, that's fine. So I'm going to take a contact from here because that one event turns it on. You know, I'm just going to put it over here. I'm going to put the mixer over here. Now this is the mixer motor, so I'll make that a little bigger and I'll put an M and then a sub M in there for mixer motor. Okay, good. So now over here I'm going to write a contact from this guy. And this is going to be my R3-1. And that's going to go over there. I'm going to have to add some more logic in here, but for now I'm just going with that. Again, one step at a time. Cool. So when that closes, the temperature's up and the motor's going to come on and it's going to start mixing. I know what's supposed to happen for a certain amount of time. Okay. So how long does that supposed to be, or whatever, 5 seconds? Now I told you guys in the description that you have to use an off delay timer. Off delay timers are pretty cool. How they work is that as soon as they get energized, the contact changes its state. And then when the counting cycle is done, the contact then goes back to its normal state. So what happens here is that I've got to turn a timer on, but the timer's also got to control the motor. So maybe I'm just going to kind of go with this a little bit. I'm going to put a timer in here. Okay, so I'm not sure exactly what this looks just like yet, but how do I get the timer to control the motor? And more specifically, with an off delay timer. So in an off delay timer, just as a side, if I had a contact here, let me just kind of put this kind of side thought in here. If I had a contact like this was a normally open. So that guy is a normally open, timed open. So this is the symbol for an off delay timer. So what happens as soon as the timer energizes, that closes. After the counting cycle, it goes back to its normal state, which is open. The other option I have is this. What's going to happen here is that goes there, this goes here, that goes there. This is a normally closed, time closed timer. And that what happens is, as soon as the timer is energized, that goes in its active state, becomes open. And then after, it gets closed again. So which one of these do we want to use to control this motor? Now think about it. I don't want the motor to be on until the timer commands it to do so. So actually what I want to do is, I want to use a normally open, timed open contact to control my motor, because normally it's open. It's not going to turn the motor on until the timer gets energized. Once it gets energized, then it's going to become closed, and it'll stay closed for the length of time the timer is counting, and then it'll go back to its normal state, which is open, and it'll turn the pump off, it'll turn the motor off, which controls the mixer. Where do I put that contact? My motor's here, where do I put it? Well, it's okay, you can put contacts in here. You know what I'm going to do? I'm just going to expand this a little bit. I'm going to run this over here. Now I'm going to erase this and I'm going to put this contact. I'm going to put that contact in there. So again, when you draw your off delay timers, let me just put that a little bit more space in there. What's going to happen is that you draw this down, but you draw an arrow pointing down. So this is T1-1, and I don't need to label it. You shouldn't actually label it, but I will anyway. This is a normally open, timed open contact. So this indicates that that timer is an off delay timer. So the off delay timer and the on delay timer don't actually look any different. In Automation Studio, you have to choose one or the other. But how you define it in a diagram, when you're actually drawing these ladder logic diagrams, is you just actually put that symbol in, as opposed to the other type of timer that looks like this. So that is a normally open, timed, closed. So after the time, it becomes closed. So that's an on delay timer. We won't even do that. Okay, good. So we've got this going on. Wait a second. Let's just see where we're at. If it gets empty, that becomes closed, and then that energized holds that so that when it is going above that, the pump stays on, the liquid stays on. When it gets to the top, I want the motor to turn off. Okay, well, I think we have that covered. You guys know how to do that, right? You're going to add some stuff there. Okay, good. Also, we want the heater to come on. Okay, so this event does two things. Turns the motor off there and it turns the heater on. Once the heater goes up here, then this signal then tells this guy to close, which energizes my timer. And because as soon as that happens, this becomes closed, my motor comes on for a certain amount of time. After that set time, it becomes open. Okay, so now my mixer just came on for 5 minutes or 5 seconds or whatever it is. Now, what's supposed to happen after that? Well, the system is supposed to drain, but that's in the next step. Okay, so that's in stage 2. It's going to drain and then it's going to fill up again. We're going to find a little bit of conflicting logic in there that we're going to have to figure out how to solve. But right now, what you need to fill in here are some gaps. Now, the parameters, the operational parameters for this are such that if the temperature goes below the set point during the mixing process, the mixer does not shut off. Okay, so we say that again. If this becomes open during the mixing process, the mixer keeps going. Because remember, the event was that when the temperature goes above the set point, then the mixer comes on. But if it goes below the set point, that event goes away. So does that command go away? No, we need to hold on to that command. Hint, hint. Okay, good. So I filled in a lot of stuff for you guys here. So I need you to fill in the rest of this. And also put a start-stop in here, and I'll give you a little bit of hint about how to deal with your start-stop, and I'll do that with a different color. So what's going on is that you've got to fill in the rest of this to make it go. Also, you may have to put another holding circuit in here somewhere, and you might have to think about the termination signal for that holding circuit. Yeah, that's actually really very important because you cannot put a holding circuit in without a termination contact. Okay, good. The other thing is that the start-stop station, you know what? Its process is not to start the filling process or stop the filling process. It just turns it on and off. Okay, good. So I just up here sneak in a start-stop. So there you go. There's your stop. Sorry. There's your stop, and here's your start. And then you're going to put a relay in here. This should actually be relay 1, and that should be 2, and then, so you're going to change these. Remember, like, I just doing this to highlight an afterthought. Often you have to kind of reiterate or change the names of some of these things because it's a dynamic process, the design. Okay, and we know that there's going to have to be a holding circuit, so that's Rn-1, and let's say that's Rn. And then from there, what you can do is you can put a contact from that relay here, Rn-, sorry, let me get rid of this. This will be Rn-, 2, right? We know that because that's Rn. Let me complete that. And then over here, you can put another one here. You can say Rn-3, and you can put another one here, Rn-4, and another one here if you wanted, Rn-5, and you can continue on actually with that process. When you build this in Automation Studio, there's no limit to the amount of contacts you can put onto a relay. But the other thing is that I want you to think a little bit about if you need all of these, because some of this is cascaded. What does that mean? Well, cascading programming is a whole other kind of programming, but the concept of a cascade means this. It could be that if this goes away, because this is controlling this rung, you don't need to have an override here. So if I were to say, if I hit stop, all of these rungs should shut down. Well, there's kind of a cascade because, dude, if I shut this rung down, guess what? This rung would shut down anyway. So I don't actually need this. I don't actually need that contact there. That's kind of a cascade method, not method, pardon me, concept. Because the cascading concept is that if you shut this off, then stuff happens below automatically. And in that, this rung shuts off if you kill this rung. Okay, so that's all I'm going to tell you. You need to fill this in. write it on Automation Studio, test it, make sure that it's tested. That's it. You don't have to draw this or whatever, that's fine. So just get this thing working in Automation Studio, download that to your computer, and yes, I know, some people are, oh Lars, I've downloaded this to my computer, but I'm not sure if you can open it. So, you know, here's how you open this. Dude, I've been working with Automation Studio for like more than a decade. I know that. It's okay. I know how to upload it to AppStream, and I know how to do all of that. So just give me your Automation Studio, just the actual file that's saved. And when you look in your directory, it'll be the largest of the 3 that's saved there. Send me that file. I'm going to then look at it, through Automation Studio. I'm going to study it and give you marks for it. Okay, bye.